You wouldn't hand a valet your house keys just to park a car. Yet for years, that's exactly what apps asked you to do. Give up your GitHub password just to check your commit history. OAuth 2.0 fixed this with a valet key. Full access to do the job, zero access to everything else. Today, 4 billion logins run on this idea. Before OAuth, giving an app your password meant giving it everything. It could read private repos, delete your projects, or change your password and lock you out. There was no way to limit what it touched, and no way to revoke access without changing your password everywhere else too. OAuth 1.0 launched in 2007, clunky and hard to implement. OAuth 2.0 finalized in 2012, the same year Instagram used it to let 100 million users log in with Facebook, no password shared. It became the backbone of every Google, GitHub, Slack, and Spotify login you use today. OAuth defines 4 players. You're the resource owner, the car's owner. The client is the valet app requesting access. The authorization server is the kiosk that issues valet keys. The resource server is your garage, holding the actual data. The client never touches your garage without a valid key. Here's what nobody tells you. OAuth security failures still happen. In 2021, a Slack OAuth vulnerability exposed access tokens for third-party apps, letting attackers potentially impersonate users inside connected workspaces. The protocol wasn't broken, the implementation was. Knowing every step of this flow is what separates senior engineers from the rest. Here's the fix: the Authorization Code Flow. Your app redirects you to GitHub's login page, never touching your password. You approve access. GitHub redirects back with a short-lived code, not a token. That code is worthless on its own, and that's exactly the point. Remember the valet key? The authorization code is the claim ticket the kiosk hands you. Useless without the secret PIN only your app knows. Even if a hacker intercepts that code in the browser, they can't exchange it for a real key without your app's client secret. Once exchanged, you get an access token, a short-lived credential, usually good for 1 hour. Scopes define what it can touch. Repo read lets an app view code. Repo delete lets it destroy history. Requesting more scope than you need is a red flag in every security review and every interview. When your app calls the API, the resource server checks the token 2 ways. Call the authorization server's introspection endpoint every time, or verify a JWT's signature locally. At scale, companies like Google skip the network call entirely. The token proves itself. Access tokens expire fast on purpose, to limit damage if stolen. Refresh tokens live much longer, sometimes months, and only talk to the authorization server, never the API. When your hour is up, the client quietly trades the refresh token for a fresh access token, no login screen needed. GitHub refresh tokens expire after 6 months of inactivity. Spotify's never expire, but you can revoke them anytime. Slack goes further, rotating refresh tokens, issuing a brand new one every time the old one is used. Steal a Slack refresh token, and it's already dead the second use. This whole flow assumes a client secret, but mobile apps and single-page apps ship their code to the user's device. Any secret baked in is instantly extractable. Attackers can decompile your app and read it. The authorization code flow as designed doesn't work for these clients. PKCE, pronounced Pixie, fixes this without a secret at all. The app generates a random code verifier, hashes it into a code challenge, and sends only the hash up front. When exchanging the code later, it reveals the original verifier. The server checks the hash matches, proof only the real app could provide. Think of PKCE as a valet key with a scratch-off code only you know. The kiosk stores the hash up front. Later, you reveal the code, and the kiosk checks it matches. Even if someone steals your claim ticket in transit, they can't produce the code, so the key never turns. Here's a trap juniors fall into. OAuth 2.0 never tells you who the user is. It only proves what an app is allowed to do. Sign-in with Google needed more than that. That's OpenID Connect, a thin identity layer stacked directly on top of OAuth. OIDC adds one new thing, the ID token, a signed JBE carrying your identity. It holds a stable user ID, plus email, name, and picture. Because it's signed by the authorization server, your app trusts it instantly, without ever calling an API to double-check. Google's ID token is verified with 0 network calls. Your app fetches Google's public signing keys once, caches them, and checks the JWT signature locally forever after. That single design choice lets Google sign-in validate logins at infinite scale. GitHub actually runs 2 OAuth flavors. OAuth apps issue classic, user-level tokens. GitHub apps are newer, acting like bots with fine-grained per-resource permissions. You can even spot the type in logs. O for OAuth, GHS for GitHub apps. Slack's OAuth authorizes your entire workspace, not just your account, and returns a bot token scoped to that team. Its real defense is rotation. Every refresh token used invalidates itself and issues a new one. A stolen Slack refresh token is a one-time use grenade with the pin already pulled. Put it all together. Generate a code verifier, redirect with its hash challenge, get back a short-lived code, exchange it server-side with the verifier, receive access and refresh tokens, then call the API with a bearer header. 10 steps in the spec, 5 moves you actually need to remember. Here's the PKCE piece in about 10 lines of Python. Generate a random verifier, hash it with SHA-256, and base 64 encoded into your challenge. Everything else, the redirect, the token exchange, is just HTTP calls wrapped around this one cryptographic trick. Zoom out and the scale is staggering. Over 4 billion daily logins run through OAuth 2.0. Access tokens typically live just 1 hour. GitHub refresh tokens survive up to 6 months of inactivity. Small design choices, multiplied across billions of requests, keep this system standing. Interviewers love asking, why is this secure if the code gets intercepted? Here's your answer. The code is single-use, expires in minutes, and useless without either a client secret or a PKCE verifier. Say that exact sentence and you sound like someone who's actually built this. Before you ship OAuth in production, lock down 5 things. Always use PKCE, even for web apps. Request minimum scopes. Store refresh tokens server-side only. Verify the state parameter to block CSRF. And rotate refresh tokens whenever your provider supports it. Zoom out one last time. Your identity sits with the resource owner. The client requests access. The authorization server issues and verifies limited, revocable tokens. The resource server trusts those tokens completely. 4 roles, 1 flow, 0 shared passwords. Then, hand over your password, hope for the best, no way to revoke. Now, a scoped, short-lived revocable token, and the app never sees your password at all. That shift is why sign-in with Google feels effortless, and why it's one of the most carefully engineered flows online. OAuth 2.0 is the valet key of the internet. Full access to do the job, 0 access to everything else. Next time an interviewer asks why the code alone is safe, you'll have the answer. Subscribe for the next deep dive. JWTs and OpenID Connect, fully unpacked.